Assalamu alaikum. We are keeping this class today for DC circuits, and this is a topic which is considered to be a difficult topic, like superposition, DC circuits. We have some chapters which are considered to be relatively difficult, and today I'm planning to discuss this chapter and also planning to do some questions of it. DC circuit mainly contain two main topics, potential divider and Kirchoff rules. So it contains two main chapters, potential divider and Kirchoff rules. So there are two main topics here. Contents are potential divider, potentiometer, and Kirchoff rules. So we're not making any detailed notes, no detailed notes are required. We are just making a quick understanding of this chapter as our just like for the paper preparation. So give a heading DC circuits, give a new heading DC circuits. The main topic of this chapter are potential divider, potentiometer, and Kirchoff rules. AC-DC comparison is not needed at this point. We are starting with potential divider. It is also called a PD controller. Potential divider is also called PD controller. I put the first revision concept, a circuit component used to obtain a fraction of voltage from the total input voltage. As it is a quick revision class, so we are not making any detailed notes. We are just making some concepts, and we might be writing only the formulas. That will be enough for this class. The main target is to recall this chapter. Remember, potential divider is like this. This is called regulator. We call it dimmer. When you move it, you can control the speed of the fan or maybe the brightness of the lamp. So potential divider is basically a voltage controller. You can use potential divider to manage the voltage across a system, like a volume button, like a brightness control button, and also a type of you can say the system which control contrast between system, so the color, temperature, etc. A potential divider works on the principle of combination of resistor in series. This is the main thing to understand. Now, the idea how we can divide voltage is simple, that I have a 10-volt supply and I put a resistor here. Now, this resistor will get all the 10 volt provided there is no loss on internal resistance. Now, if I put two resistors in series, similar resistors, they will get 5 volt and also 5 volt. The two resistors will get 5 volt each. The two resistors are in series, and the series circuit is now dividing the voltage. Now, in series combination, voltage is directly proportional to resistance as current is constant. So we have a concept that V is equal to IR. In series, current is the same. So V is proportional to R. This is the second main concept of a potential divider, that when you alter the resistance, suppose you increase the resistance or you decrease the resistance, you will get a voltage change. Greater the voltage, greater the resistance, greater is the voltage. Now, this formula is originally a formula for mathematics, the ratio formula. and we use it here to find the voltage across a resistor. So give a heading potential divider, give a heading potential divider, and copy this screen. Let me know once you have copied.
Yes, sir. Copied.
Copy. Good.
Done, sir.
So these are the two formulas. Now, potential divider is a slider mechanism. Potential divider is a slider mechanism. As mentioned in the start of the class, this is called a slider. We have a slider in every device nowadays, like a volume system, sound system, mobile phones. This is called a slider system. Now, this is the total input voltage. This is the total input voltage, and this is the output voltage. The theme is there that first the two resistors will divide the voltage, then slider will make a parallel loop. Slider will make a parallel loop to take out the desired voltage. So suppose that I put 10 volt here, and suppose it gets 7 volt, then it will get 3 volt because the total is 10. The slider and the second wire are across this. So it is getting 3 volt. This is the main idea of potential divider. A slider mechanism can be a slider in a sense and also a pin. You must have seen those pins which we use for our headphones and other devices, which we call jockey also. Now this pin or slider can change the position. This is how a potential divider works. We can change the position of the slider, and by changing the position of the slider, we can change the output voltage. We can put a voltmeter here to check how much voltage is being shared across the lower resistance. Now, voltmeters are considered to be high resistance meters. Virtually, they have infinite resistance. Why infinite resistance? So that current remains zero. You can use a number of resistors depending upon the clicks. You must have seen the clicks when you are using the potential divider in your car and you want to speed up the AC fan or you want to speed up the heater. So you feel this click click when it moves. So it actually depends upon the number of resistors. Also, there is a choice of single long resistor. Now, this is a single long resistor, and I can show you the common application in our computer also. You can look at my desktop and you can see there is a slider. Look, this slider. This slider is actually a potential divider. This is called a single. This is called a single long resistor. So when I move the slider up, when I move the slider up, when I move it up, here I will get more voltage, and if I move it down, I will get less voltage. This is a very common slider with a sound system loudspeaker, and if I move it, I will get more sound or dim sound. Sliders are used with different combination. This is a circular slider, and it is designed to work in a small place like this. Now, concept of current division. Oh, just like a minute. We have to first make a slider concept. As mentioned, we are not making any detailed notes. We are making quick notes. So you have to now copy this screen.
Done. Yes, sir. Copy.
Right. So this is called the slider mechanism. And we can use a single slider, long slider. We can also use number of resistors, which we call normally clicking slider. As mentioned, that slider is an option. Slider is an option. You can use the pins also, the jockey also, which can be taken out and you can connect it to a new position. Now we are moving to concept of current division. What is the concept of current division? This is a circuit and this is called a slider. This is called a slider and you can see a 50 ohm resistor slider is on it. Now let's suppose 5 ampere current is coming up. It will pass through the first resistor, but when it reaches the point P, some current will go through the filament lamp and some current will go straight because current divides in parallel. Now, the concept is there that when you make a loop, because you are making a potential divider, because you are making a potential divider, so you need to make a loop. As you are making a loop, you must have to make a parallel arrangement because the loops always come in parallel. In parallel, current divides. So whenever a slider mechanism is made, it divides some current. Applications of potential divider. Potential divider has three main applications: heat sensor, light sensor, and potentiometer. First, we talk about heat sensors. Heat sensors normally use thermistor. I hope thermistor is in memory. Thermistor is a thermistor. Thermistor is technically a heat sensor. It is a semiconductor. And when you talk about negative coefficient thermistor, when temperature increases, its resistance decreases. So the resistors are in series as usual. Potential divider always work on resistors in series.
Copy, sir.
Heat sensor is something which is using heat sense something which is using a thermistor whose temperature changes along with the resistance. So when temperature increases, its resistance decreases. Potential divider works on a main idea which should be properly understood, that potential divider is actually not a device like a voltmeter, like an ammeter. Potential divider is not a device. It is simply resistors in series. It is simply resistors in series. And this is a very nice concept to understand, that there are two combination of resistors in parallel and resistors in series. Suppose you are teaching in a class. When you are speaking, all people are listening the same sound. So there is no division of sound, no sharing of sound. We are in the same system. This is called parallel combination. In parallel, voltage is the same. But if you have a packet of chocolates and you start dividing it in the students in the class, now the packet will decrease. This is called series combination. In series, voltage is divided and conserved. Now I have a thermistor, and I have a resistor in series. This capital R is called compensator. This capital R is called compensator. Now I start from the thermistor and you have to ignore this relay, not required anymore. Now what happens when heat is falling? Now when heat is falling on the thermistor, the temperature increases. As a semiconductor, when temperature increases, resistance decreases. What is the rule? Voltage and resistance are directly proportional. When resistance decreases, voltage also decreases. When resistance decreases, voltage also decreases. As a compensator, voltage across this capital R will increase because it is in series. So suppose that the circuit is like suppose that the circuit has 10 volt, and if it is 7 volt, it must has to take 3 volt because the total has to be 10. Similarly, if I change it and suppose that it takes 6 volt, then it will take 4 volt. It will take 4 volt because the total has to 10. This is called compensator. Now, when voltage increases, the output voltage also increases. So the device will be on. So what happened? In this circuit, when heat falls like a fire, may God not, the temperature will rise and the device will on. This circuit is suitable in a fire alarm. This is called potential divider. This is called a potential divider, and it is a high temperature circuit. Now look at the position of the thermistor. I have shifted it down. The same thing there, that when heat is falling on the thermistor, the temperature increases, resistance decreases. Resistance and voltage are directly proportional, so voltage also decreases. As a compensation, voltage will increase. Voltage will increase. Now, the slider is covering this resistor. So the output voltage will decrease. The output voltage will decrease. So the device with temperature, the device will be off. So this can be a circuit in electric geyser, electric kettle, where the temperature rises and you have to stop the device. Potential divider, interestingly, is considered to be a processor. It is considered to be a processor. For example, if you are a regular user of electrical devices like toaster, like electric kettle, so then you understand that actually all electrical heaters have an automation, like the electric grill, the electric kettle, it has to stop when water boils. So there you need a heat sensor. Now comes light sensor. Light sensors always use LDR. LDR is a light dependent resistor. LDR is considered to be a semiconductor. LDR is considered to be a semiconductor whose resistance decreases. Resistance decreases as brightness increases. Whose resistance decreases as brightness increases. Look at this one, LDR. Now I have a compensator and I have a LDR. I will start my discussion again from light here. Now suppose light falls on it, it's an LDR. Resistance of an LDR decreases in daytime and increases at night with bright. So when light falls on it, main link. Now what will happen? What will happen that when resistance decreases, voltage also decreases, and there the compensator will compensate it. Voltage will increase up. So the slider is here. So the output voltage will decrease. So what will happen? When voltage is decreasing, the device will get off. So suppose it is the daytime, it will switch off the device. And when it is the night time, it will automatically on the device. That is a very common circuit in street lights. In street lights, in the daytime, they have to go off. In the night, they have to go on. Similarly, the circuit can be reversed. Now we come to potentiometer. This is a famous topic, and normally it always give a tough time to everyone. Potentiometer is an application. Potentiometer Potentiometer is an application of potential divider. Potentiometer is an application of potential divider, and it is a setup. It is an arrangement to compare potential difference. Like we can talk about manometer, which is used to compare pressure. It is a pressure comparator. So give a heading potentiometer. Give the heading potentiometer, then copy the definition.
Done, sir.
Potentiometer is an arrangement. Then if you are back, let me know if you have copied
Yes,
it
sir.
also.
I have, sir.
Good. Potentiometer is an application of potential divider. Then first concept comes, then why we need a device for voltage when we have a voltmeter, and above all we have CRO. CRO is over extraordinary accurate. CRO is an extraordinary accurate device for measuring voltage, but we use potentiometer here. The response, the reason here is the problem with the potential voltmeter. When you connect a voltmeter, look here first, this circuit, you are giving 6 volt, 4 volt on the lamp and 2 volt on the resistor. The voltage is divided like that. Then you attach a voltmeter across the lamp. Interestingly, the 4 volt now decreases. The voltage decreases from 4 volt, and this voltage increases from 2 volt. Why? Voltmeter is a good measuring device, but the problem is that voltmeter comes in parallel. I just explained that potential divider, whenever it makes a loop, the problem comes with the loop. Within the loop, resistance decreases and voltage also decreases. That is why a voltmeter actually disturbs the voltage of the device. So even though voltmeter will measure accurately, but it will never be accurate to measure this 4 volt because it is sharing the parallel circuit. So that is why they thought about comparison. It is called null method. They thought for a comparison, and this is the circuit of a potentiometer. This is called a driver cell. This is the circuit switch, and we have a rheostat. This is a long marked scale. This is a long scale, and then our potential divider is there as a slider, and then a galvanometer is there. Galvanometer is very sensitive, and it can detect even a small amount of current. This is called rheostat. This is called rheostat. You can move it, and you can check its slider. And you people have obviously used it in the lab also. Now this is the circuit. I have closed the switch. Now the circuit is on, and this is a rheostat. And then you have a scale. You have a scale, and look at the screen that we can move the slider forward and backward. This is our slider. We can move it forward, we can move it backward. So what we have to do, we can move it forward and backward until the galvanometer shows 0. I repeat, this is called null method. Arrange the apparatus as shown. You have a long wire PQ with a marking on it. You have to move the slider forward and backward until the galvanometer shows 0. Why the galvanometer will show 0? Actually, as per the length, this voltage is facing some voltage from here. So suppose whatever the voltage of the target cell, when Px, look, this Px, when Px is giving the same voltage as the voltage of the target cell, the difference in voltage would be 0. For example, that this cell has a voltage of 5 volt. You are moving the slider forward and backward. When the voltage here also becomes 5, this is a positive terminal, this is also positive. So 5 minus 5 will become 0 volt. So the two voltages are 0. That is a very big contrast. So the slide, the galvanometer will show 0 deflection. At this point, you will stop and you will apply a ratio formula to get the voltage of the cell. The voltage, total voltage across the wire, that we can find it from the source cell, and we can use it as a ratio to find the voltage across Px. Using this method, we can find the voltage across the target resistance. This is called slider mechanism, and this is how a potentiometer is working. Potentiometer uses galvanometer as a reference. This is called a potentiometer. Then we talk about Kirchoff laws. Give the heading, Kirchoff laws. Kirchoff laws are famous. Kirchoff laws are famous for solving the circuits. And in our AS physics, this topic is considered to be a challenging topic. Normally, Kirchhoff is not very dangerous for the last few sessions because other chapters are giving actually more difficult time, but it's famous for its complexity. Kirchhoff laws, give the heading. Kirchhoff laws are the basis of analysis of the circuit. The first law says in a network of circuits, the total current flowing into a junction is equal to the total current flowing out of it. This is a conservation of charge. And you people obviously remember, whenever this topic comes, he is always interested in asking you to write the law. No doubt, Kirchhoff is the main topic behind all circuit evaluations, even series, parallel, they all are output of Kirchhoff laws. So give us side heading, first law. Give us side heading, first law, and copy this.
Done, sir.
Okay.
Yes, sir. Yes, sir. Done.
Kirchoff law is a conservation of charge. This is called Kirchoff law, and it is an output of. This is an output of law of conservation of charge. Total currents entering a junction is equal to total currents leaving the junction. You have to copy this.
Done.
Yes. Yes, sir.
This is called the junction law, and total currents entering a junction is equal to total currents leaving the junction. Now, we are talking about second law. Second law is related with a loop or a type of a circuit which is closed. In a loop, the voltage is divided and conserved. The concept is very obvious, but obviously it's a law. This is the power source. Now, in a circuit, what happens? Some of the energy is dissipated. Some of the energy is dissipated within the cell itself. Some of the energy is dissipated within the cell. But if suppose there is no internal resistance, then cell will not waste voltage. Some voltage will take up this resistor. Some voltage will be taken up by the second resistor and some by the third resistor. These are resistors with color bands. Now, these are called connecting wires. Normally people do not consider wires, but wires are like resistors. Wires do carry some voltage. Long wires, especially long wires, carry a lot of voltage. So there are resistors in series with connecting wires with a power source. Now, if the power source has EMF E, now it will take some voltage, it will take some voltage, it will also take some voltage. Logically, it's dividing some things in a line. So EMF will be equal to V1 plus V2 plus V3, assuming there is no resistance in the circuit and assuming there is no voltage loss on the connecting wires. So this is the spectrum. Who are the contributors? Who are the shareholders of the voltage? Now you have to give a side heading, second law, and copy this.
Done.
Yes, done.
This is the potential difference sharing, said that who are sharing the voltages in a circuit. Again, I say that how AS questions are designed, they're always designed in the low level patterns. So always they look for low level things. So normally you will find questions where we talk about resistors only. So now this is a potential circuit. It's a loop, and the circuit has an EMF capital E. There are two shareholders, R1, R2. It's a closed loop. So sigma E is equal to sigma IR. What it means, the second law says the total EMF is equal to total voltages. You have to copy this screen.
Done.
Yes, sir. Done.
Okay. Now I have expanded it. Current is the same. IR. R is the internal resistance. IR the voltage loss within the battery. IR1 is the share of the first resistor. IR2 is the share of the second resistor. So you have already copied the circuit. You have made the equation. So just copy down this equation also. Copy down this equation.
Done.
Yes, sir. Done.
In all the latest past papers, this is the bit advantage of doing a long series of past papers from 2012 to 2023, that you will find two important syllabus changes and you will understand in every topic what they are actually asking. This is actually a skill. This is a skill which every student needs to get a good grade. In all the latest past paper, you will see that examiners are not interested in Kirchoff detail working. They are interested in equations. So all in the new paper, you will find equations. Second law is a law of conservation of energy. You have to copy this.
Yes, sir.
Important consequences of Kirchhoff laws. The first is a very important and a very famous concept, that like polarities are always subtracted. Like polarities are always subtracted. What it means, like polarities are always subtracted? It means that if you connect the cells plus to plus, if for a common person we say wrong polarity, the device will not work because the voltage will become zero. But here in our syllabus, it's a topic proper. So when you connect the cell like this, the EMFs are subtracted. Maybe it is a case that it is a possibility to get a zero, but maybe a some voltage, but zero is the close. So you have to see the first rule. Second, unlike polarities are always added, which is called the right polarity -2 plus. Then EMFs are added. Number 3. Look at the third one. Now this is a parallel circuit and the switch is open. I have closed the switch and look carefully that movement of current. No need to copy it, but look the current. Now current is dividing. This is called a parallel circuit. Kirchoff was the person who made this law, the first law, and on the basis of first law, they made a derivation, and that was the all-time famous formula for parallel circuit. Derivations are very rare, but whenever they come, it's a free bonus marks. Normally derivations are rare. Sometimes in the whole paper, there is not a single derivation, unlike A2, where derivations are back to back. So, but anyways, derivations have to be remembered. Now, I have taken the first law and make the current division. Then you can see the voltage is the same because in parallel, voltage is the same. So I have taken V common and V cancels out. This is called the derivation of parallel circuit. Look at this diagram. This is called resistors in series. Resistors in series R1, R2, and R3, and there are 3 voltages V1, V2, and V3, and there is a loop. The voltage is divided and conserved. So look at this diagram closely. This is the application of second law. This is the application of second law. This is the application of second law. Now, according to Kirchoff's second law, V is equal to V1 plus V2 plus V3. This time, current is the same. So we take current common and cancel it. This is the derivation for resistors in series. Number 5, the sum of all the voltage drops across a loop is 0. This is a very interesting loop. There is no power source in it. There is no power source in it. And if you add all the voltages, the output is 0. Number 6, if there are 2 power sources, the source of higher voltage would be charging the lower voltage one. This is a very important concept. It has appeared many times in the paper. It has appeared many times in our past paper. The concept says that when there are 2 power sources, like in our house, if you have a KSC power supply, the main power supply from power plant, and also you have a generator. Then there are 2 power sources, a standby generator and a house main input supply. Or maybe you have, suppose that you have a main supply with a UPS. Now the power source, which is at the higher voltage, will become the source. And the second one, which is at the lower voltage, will be on charging. So this is the concept of a single loop. Look at the diagram. Here, one source, one voltage, the 7 volt is the source, and the lower one is on charging. This is how we solve it. E1 minus E2 is equal to IR1 plus IR2. Why we are subtracting? Because positive is connected with positive. This is called charging circuit. For example, a car battery system, there is a generator in the car and there is a battery in the car. When you switch on a car engine, the generator starts and the generator produces electricity to charge the battery, but the generator is at a higher voltage. When the car stops in a way and engine goes off, the battery will become the source. This is called two-source system, which is commonly in our cars, in other electrical systems, in electric cars, and in our houses also, like a standby generator with a lift. As soon as the main power goes off, the generator becomes the actual power. But until the electricity is coming from the source, generator will be on receiving side. It will stay silent. Now you have to look at this diagram, and you have to first copy this screen. Copy this screen.
Done, sir.
अच्छा,
Then copy this screen.
अच्छा,
Done.
Okay. All energy losses are neglected until question says else. There are losses in connecting wires, in the power source, but we neglect all the sources. So the internal resistance, small r, is a factor. If it is there, you have to consider it. In this diagram, we have not considered the internal resistance. But if examiner takes it, you have to consider it as a proper resistance. It is not necessary to follow the conventional direction of current. That is to say, in solving a circuit, current can be taken plus to minus. There are two reasons for it. One is the concept of conventional current reversal, because already that was an assumption. Secondly, when there are two power sources, it is not necessary that they both are providing the power. They can obviously, but not always. So current direction can reverse. You can look on this circuit. You can see the current is coming out from negative, which is not a convention, but it is possible in Kirchoff. In case of a slider arrangement, it is necessary to remember to divide current in parallel lines. It's a very important concept. Look at this circuit, a famous circuit, a past paper diagram, obviously. Now, this is the cell A, this is cell A, and this is the resistor. This is cell A, this is the resistor, the little resistor, and we have a 0.9 meter length, which is till J. Originally, it's 1 meter long. What happened when current reaches the position X? When current, sorry, when current reaches the position X, the current will be divided I2 and I3. Current will be divided. Why current is divided? Because it's a parallel loop. So whenever there is a slider, there is division of current. Now give a heading, examples of Kirchoff laws. I have shared this file on WhatsApp. You can check it and open it. It would be ideal if you solve on the device if you have. If you can write on the device, it will take much less time because copying this and working on it will be a time-consuming thing. So if you can open the file on any writable device, it will be very good. This is the first example, and I am first marking the junction at P. You have to work with me along with the question, so we can discuss the question.
Yes, sir.
Mark the junction. Mark the junction at P, and let's try to make the first law application. Kirchhoff first law. Write down an expression. Write down an expression relating I1, I2, and I3. Okay, now help me to make an equation here.
Would
The
it be
junction is at
I1
D.
plus I2 equals to I3?
I1 plus I2. Yes, Zen, what do you say? Okay. So we have the first equation, I1 plus I2. I1 plus I2 is equal to I3.
Yes.
Now he's talking about a loop. He's talking about a loop A, B, E, F, A. A, B, E, F, A. I have marked the loop ABEFA. You can look at the loop, and there are two resistors R1, R2. The logic should be remembered. A resistor will always connect with the closest current. So I3 will be for R2, I1 for R1, and then you make the equation like this. Copy the equation only.
Yes, sir, copied.
Now,
Done.
work out this bigger loop ABCDEFA. I will cancel out this and look, that's ABCDEFA, the bigger loop. I have cancelled the middle resistance. Look at the polarity plus and plus. You can assume that E1 is bigger, or you can assume E2 is bigger. It's your choice. You can say E1 minus E2, or you can say E2 minus E1. It depends upon you, because he has not mentioned it. So if you take E1 minus E2, you will take this current with this resistance. Then you will take this resistance with this current. So now try to make an equation. But first decide E1, suppose that E1 is greater than E2. Now make an equation.
Would it be E1 minus E2 equals to I1 R1 plus I2 R3?
Okay, then your feedback needed.
Sir, I'm following you. साथ साथ उसके नाम स्टडी साथ साथ.
Can't hear you.
Better now, sir.
Have you made the equation?
I made the diagram. I'm following you साथ साथ. आप करते हैं तो मैं साथ साथ कर रहा हूँ.
No, but we need the equation, na? ACDFA, the bigger loop.
जी जी.
Now we suppose that E1 is greater than E2. Look at the equation. E1 minus E2 is equal to I1 R1 minus I2 R3.
Why do we minus it? Why not add it? The I1
Because
R1.
the currents, look at the arrow and look at the arrow. These two currents are actually facing each other. Currents in opposite direction are subtracted. Currents in opposite direction have to be subtracted. They are not vectors, but still they have to be subtracted. So I1, I2 will be subtracted. Now, why I1 minus I2? Why not I2 minus I1? We have supposed even bigger. So I1 would be bigger than I2. So compare the equation. Now we have a new question. This is, and this is, I have shared some documents with you on the WhatsApp, some notes also, because I always tell my student that make one topic solid, just like you are doing one chapter. So a quick revision video, some short notes, some past paper. So you solidify one chapter. This is what I am doing here also. So now you have to look for this. Now this is the question. Find the PD across 8 ohm resistor. If you want to copy this question, copy it, or you can solve on the device. Both features are available, but we have to start with the same method, that you have to first locate a junction, and just commonly I show you the currents and the values and the junction, so we can work out. First, copy this. Find the PD across 8 ohm resistor. Now copy this. I'm just coming and start the first law. I'm just coming. Compare the first equation, I1 plus I2 is equal to 3. So please confirm, are you getting the same equation?
Yes, sir.
Then did you get the same equation? Now I have shown a bigger loop. Please make an equation for me in this loop, the second law.
would it be like E equal to IR? You find I using 4V and 2.
Okay. And you have to consider 2 ohm also. So 4 is equal to 2I1 plus 8I3. Always take the neighbor current for every resistor. So compare the first loop equation. Then if you are back, please compare the first equation.
Yes, sir, I am back. आज को पता नहीं बहुत technical issues हैं.
But you should see this if possible on any wired connection.
I am on the wired connection. So मेरे device का issue है. It's मेरी laptop जिसमें मैं काम कर रहा हूँ.
So please compare the equation.
So, right.
We made the first loop equation. Okay, now move to the two equations. One is you can simplify the equations. As I said earlier, solving the equation is not a big thing now because they're not asking to solve the equation, but some basic maths is needed to remember, just like we made this equation. So you can take common and you can simplify the equation. Now there are two equations. You have to you should copy this also.
Done.
Now this is the second loop. So please now make this idea that the current in the 8 ohm resistor is I3. Okay, the current in the 8 ohm resistor is I3. And what was the current in 1 ohm? It was I2. Look at the equation, make a good sense. Then if you want to copy, you can. This is 1 ohm, it is connected with I2. This is 8 ohm, it is connected with I3. So copy the loop and the equation.
Done, sir.
Yes, sir, also done.
Now we have three equations. We have three equations. I have summarized them here for you. So if examiner says, you should remember that in our O-level maths, we can solve equations, and also in a calculator, we can solve it. So these are the three equations. How we solve it? We put the first equation into second, because we have to replace I3. Once we replace I3 from second equation and the third equation, we can solve them simultaneously. So please copy it and try to
Yes,
solve
sir.
it quickly. I'm just coming, copy it.
Yes, sir.
Sir, could you
Note down the
explain?
values of current. Note down the values of current, and you can try at home if you are getting any problem in simultaneous equation, even though it is a topic, but we should not waste time on that. But I have shown you the values. This point is important to understand, that what is the significance of this negative sign. If answer comes negative, if any of your answer comes negative, it means that the current, if any of your answer is coming negative, it means that the current is reverse in direction. So what we had supposed, the current direction, this is, look at that original diagram. This is I1. So it means the actual current is this way. Note down the value of I3 also.
Yes, sir.
Done.
Then find the voltage.
It's 2.5.
Locate the voltage is there. We know the current which is going through the resistor, and we have the resistor 8. When we started the question, this was the question, this was. So 8 ohm is the resistor, and the current coming here was I3. So 8 ohm into I3. Calculate the values of I1, I2, and I3. You have this file, and as mentioned that you need no need to copy the circuit of if sorry, you no need to copy the circuit if you can solve on the screen, but obviously some working is then needed if the you don't have a right now presently, if you don't have a writable device. This is the circuit. Now I will take the junction. I have marked I1, I2, and I have 3 currents to be known. So please update the circuit, copy or update the circuit.
Yes, sir.
I have taken the junction at F. So you people also take it at F, and let me help to make the first equation. Kirchoff first law. Look at the equation. The first equation. Look at the first loop. Make the equation F, C, D, E, F. I'm talking about this lower loop, this one. It has one power source and one resistor. So 27 I'm using. Consider the loop, make the equation and compare with my answer. So now let's talk about the other loop, A, B, D, E, A, the bigger loop. Now cancel this one and take the bigger loop, cancel the resistor, cancel this voltage, and take the bigger loop and then make an equation and compare with my equation. I need feedback. Once you make it, please inform me on the chat or on the mic.
So you say, can you repeat what you said? The audio इतनी तेज नहीं है.
Then actually you need to make an equation. Look at the screen. The loop is A, B, D, E, A.
ठीक
Okay.
है.
This is the upper loop. Look at the voltage 24, which comes in the equation start. Look at this 2I. The current is I1. So look 2I1. Then you go down. This is I3. This is 4. And you can get 4I3. So this is the equation for the bigger loop. I am cancelling this because it's not part of the loop. So name the loop and make the equation and compare with the screen.
Yes, sir, I'm getting the same thing.
Then please reply.
ऐसे में क्या? I have to make the equation of A, B, D, E, A, or I have to make the equation of A, B, C, F, A. So am I audible?
Yes, I got your point, but are your equations matching?
आपके साथ सर?
Yes,
सर
definitely.
आपके साथ तो मैं I'm checking मेरी जो नहीं मैच करी वो तो I don't carry forward. I cut it off and I redo
So
it.
now we have two equations. I'm again showing some basic simplification, even though there is no chance, in my opinion, that he will go on this side. He will only ask to make the equations and leave. But anyways, this is called elimination method in our O level, and you can use it to find the resistance. Now, this is my fourth example. No need to copy it. Just take the junction at A and make the equation for Kirchoff first law for me. You can notice there are three loops. There are three loops and I have taken one junction. First, tell me what would be the equation for the first law, Kirchoff first law.
I1 plus I2 equal I3.
Okay, good. Zain, your
Are you asking me, sir?
tell me what is the equation for junction A.
Junction A meaning the loop ABA, right?
Junction is a total current entering the junction. Total current entering is equal to total current leaving. Look at this current. Look at this current and look at this current.
G.
So talking about talking about the first junction, first law, Kirchoff first law, total current entering a junction is equal to total current leaving the junction. So then make the, now talk about loop number 1.
It will be I110 plus I340.
Okay. Loop number 1, 10 is equal to 10 I1 plus 40 I3. If we talk about loop number 1, this is the resistance, this is the current connected. Then this is the resistance, this is the current. So 40 I3, 10 I1. 40 I3, look at 40 I3, 10 I1. It's equal to 10 because it is the input. So it's very simple. Just remember every resistor goes with the neighbor current. Now, let's talk about loop number 2. The voltage is 20.
So
That
would
will
this
be
be 20 I2 plus 40 I3?
20 I2 plus 40 I3. Okay, fine.
Yes,
Good.
I forgot to mention equal to 20. Sorry. I
Yes.
forgot to
But
mention
now
that.
write the equation for loop number 3.
Will it be 20 minus 10 equal to I110 minus I220?
Okay. Because when you take loop number 3, this will be cancelled. I1 R1 minus 20 I2, 10 I1 minus 20 I2, they are facing currents. What about this 10 and this 20? They are plus to plus. So will they be added or subtracted?
Subtracted.
Yes.
Plus 2 plus is added, and I think sorry, plus 2 plus is subtracting, and so is minus to minus, and that's for same signs. Right?
Now compare the equations, please.
Yeah, I'm getting the same thing.
Copy down the answers for later check.
Sir, did they ask you to solve for I1, I2, I3 like this using simultaneous equations?
They used to, but not in any latest paper. That's why I'm not going through this work. Nowadays, they just go for give the equation and it's over. Because solving the equation is now on calculator also. It's a calculator function also. So they are not much interested in that. Now you have to look example number 5. Please look on this example. First, copy these answers.
Done, sir.
Now copy this one.
Yes, sir.
Look the equation. I have taken the junction at P, and this is the first law application. As visible, there are 3 loops. One left one, right one, and one the bigger one. This would be loop 1, this will be loop 2, and this will be loop 3. Compare the first law and then help me to make the equation of the loops.
12 is equal to 10 I1 plus 20 I2 for first loop.
10 I1 plus 20 I2 is equal to 12. Okay.
For the second loop, how do we make it because there's no resistor with I3?
There are 2 resistors.
But I2 is
I2 will
closer
come
to
down
20.
here, but I2 will not be. This is I3 which is coming from here now. A loop after the junction, you have to take the current which is taking care of that junction. So 5 ohm is getting I3.
Okay, so 10 is equal to 5 I3 plus 20 I2.
Sir, how do we know that 5 ohms is getting I3?
Loop, look the wire na. This is a common wire. Look at the wire, then it's a common wire. If I walk on this wire, I reach here. So from where I3 is coming? I3 is coming from this wire. Until you touch a roundabout, you touch a junction, the vehicles are the same. A vehicle entering an underpass will be coming out from the other side. There is no junction in between. But after the roundabout, some vehicles goes on one side, some on the other side. Please compare the answers. Quickly compare the answer. Time is getting over. Quickly compare the answer.
Yes, sir, I'm getting the same thing.
G. Then your turn. If you can show me if you can compare.
सर मेरा ये हल्का सा गलत था उसका इनकम्प्लीट छोड़ा था bro. जैसे पहले गलती की थी कि equal
But you have the diagram. No problem. Just see the working. The sheet is with you.
ठीक है sir.
These are the currents. Now look at this question and try to do it on your own. Let's take the junction at F and quickly try to do on your own. I'm just giving 2-3 minutes and I'm coming back. Please try to do this question on your own. Show me all the equations. Look at the answers, and I have taken junction at F. So compare the answers and give me the feedback.
Yes sir. Still fine. Right.
Matching?
I'm getting the same thing, sir.
So we stop here. There are still, I think, 1 or 2 questions. Just let's talk about the bigger loop. 20 minus 12 is equal to 3I2 minus 2I1.
I'm getting the same, sir.
So we stop here and we will inshallah continue in the next class. Allah Hafiz.